When developers take a vague business requirement and jump straight into a code editor, the result is usually chaos. They over-rely on AI agents, edge cases slip through the cracks, and the resulting architecture quickly becomes difficult to maintain. To prevent that, you write an implementation plan. It serves as a direct bridge connecting the raw requirements of what is needed to the practical steps of how you intend to build it. This blueprint forces you to map out exactly what you are about to do. You will define the necessary database changes, the specific UI states, the API endpoints, and the testing protocols before a single line of code is written. A reactive coder starts typing and hopes for the best. A strategic engineer secures the direction, breaks the work down, and controls the scope from the very beginning. Notice the current context section in the standard implementation plan. Before building anything new, you must catalog what already exists, existing code, APIs, and limitations. With ground truth established, the proposed approach summarizes your specific development direction. Divide the monolithic task into development slices. Slice 1 is foundational. Define your database models and back-end APIs. Slice 2 isolates the front-end user interface, focusing on screen components and forms. Finally, Slice 3 secures the feature with business validation and QA checks. The rigid rule of this system is that a single slice must be independently testable. You do not start building the UI in Slice 2 until the APIs in Slice 1 are functional. Carving the work into these strictly testable phases prevents development paralysis. It gives you clear milestones and actively protects the project from scope creep. In the front-end plan, map out necessary screens, components, and UI edge states like loading or errors. The back-end plan dictates exact API endpoints, business logic, permissions, and failure logging mechanisms. Finally, the database plan defines new tables, fields, and relationships. If your feature integrates artificial intelligence, fill out the AI plan. Specify the model's purpose, precise prompt workflow, and expected structured output. Crucially, you must document fallback behavior to ensure the application remains functional if the AI hallucinates or fails. If you only design for the happy path where everything works perfectly, your application will break in production. Anticipating external failures, invalid data, and UI edge cases is the core function of a resilient architecture blueprint. Formulate your testing plan by defining unit tests, manual QA steps, and sample inputs. Next, log potential blockers by identifying project risks and listing external dependencies. Finally, define the agent usage plan to create strict boundaries and context rules for AI coding tools. Finally, establish the definition of done. You write down the exact criteria proving the implementation is complete and ready for deployment. Setting these rigid completion metrics replaces guesswork with a controlled, professional engineering process. Once you complete all 17 sections, you hold a comprehensive roadmap. You have converted a vague idea into a tightly controlled development strategy. This finalized plan dictates your precise build order, your exact technical requirements, and the specific risk mitigations necessary to succeed. As the summary points out, a successful implementation plan values extreme clarity over obsessive perfection. It needs to be clear enough to guide your workflow, but adaptable enough to evolve when you encounter friction. By establishing the build order and testing criteria before the work begins, you provide the team with a clear path through the technical noise. This transition from reactive coding to a documented strategy is how a technical lead ensures that even the most complex requirements result in maintainable, production-ready code.